Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Ray. And Ray, if somebody needed to get a hold of us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Toll free 1-866-636-6284. Email dothemath@corn.org. We're online at dothemath.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, thank you very much for that. Ray, where do you go to school and what grade are you in?
I go to Stockdale Elementary and I am in 5th grade.
You're in 5th grade. How's 5th grade going?
It's going good.
Yeah? What's so good about it?
It's hard.
So you
It's
like
hard.
it?
I like it hard. I like it challenging.
Oh, good. All right. Now, when you bring that up, the challenging thing, I see that you've got a GATE t-shirt on.
Yeah.
Right. So how do you like that program?
It's also way more challenging, but it's good.
All right. So you like that extra work and that extra challenge and stuff like that?
Yeah.
Good. Well, that's a very good attitude to have towards school overall, that everything is going pretty well right now.
Yes.
All right. You are working on fractions.
Yes.
And you said that you know how to add them and subtract them.
Yes.
But you've not yet started multiplying or dividing them. And even before you start doing that, in your book, they want you to estimate them.
Yes.
So what we're going to do is we're going to have you do one of those problems right now.
Okay.
All right?
Yes.
I will give you a choice. 2, 3, 5, or 6.
I always start with the first one, so let's just do 2.
All right, we'll start with number 2. All right, so if you guys want to put it on the board, we have 1/8 plus 1/4. So Ray, you might want to just go right up to the board and you can start working. So you're going to go on the other side there, Ray?
Oh, okay.
Yep. There you go. Grab a pen and you guys can start writing up there as whatever you want to do. So estimate it. Don't solve it.
Estimate.
Yeah, we don't actually need to find the actual answer. So Ray, what does that word estimate mean?
It means, it's basically like round. It's like, yeah, it's basically like round.
Gotcha. So if you had a number, like let's say over here, right, 3.7, and someone said round that or estimate it, how would you do it? Any way you want.
I would just, if it's 6 and up, then it's rounded to the farthest number, and if it's 5 and below.
And you're looking at this number here, right?
Yeah.
So this number here is going to round the 3, and is the 7 going to round the 3 up or the same?
3 up.
It's going to go up, right?
Yes.
So this would round to 4.0.
Yes.
And that's just kind of estimating. 3.7 is pretty close to 4.
Yes.
So when you think about estimating fractions, we're going to do something very similar. Okay? Very similar. How about these numbers here? Any idea at all about how you want to estimate or round them? What is 1/8 close to? Any ideas?
No, I don't have it.
Well, is it a small fraction or is it a big fraction? How about this? Is
It's
it
a
bigger
small
than?
it's
kind of a
small.
small one, right?
Yeah.
Is it, so would you say it's less than a half?
Yeah.
Okay. So we know that 1/8 is less than a half. All right.
Yeah.
What about 1/4? That's less than a
it's-
1/2.
Yeah, it's less than 1/2, but it's bigger than 1/8.
That's true. Okay. So we have 1/4. You're saying is less than a half.
Yes.
This is 1/4. But you're also saying it's bigger than 1/8. Okay. So this is some good information to have because we want to make sure that at least we have an idea about what's going on here. So if you had to estimate, okay, let's say we have 3 choices here. Do you think that this answer is closer to 0 or 1/2 or 1? See how I just kind of cut that into 3 different pieces?
Yeah.
Is it a really small, if we're not going to actually do the problem, right? But do you think if we add these 2 together, are we going to be closer to 0 or 1/2 or 1? What's one of these things you could probably cross out? Which one do you think it's probably not going to be?
It's probably not going to be 0.
Okay, why is that?
Because if you're adding, you're not going to get 0.
That's a good point.
Unless you're adding
So
0.
we'll cross out 0.
Yeah.
Any other ones you can cross out?
I mean, you don't need to cross out both of these.
So it could be one or the other, right?
Yeah.
Now, again, you told me that 1/8 was a small number, right? What about 1/4? Is it a pretty small fraction, or is it bigger than 1/2?
It's bigger than one, or no,
told me
it's
here it
smaller
was-
than 1/2.
Yeah,
but
so it's not too tremendously big, huh? We're kind of dealing with 2 pretty small fractions,
Yeah.
right?
Yes.
So are you going to be closer to 1 when you add them up, or do you think you're going to be closer to 1/2?
Probably gonna get closer to 1, or 1/2. I meant.
Yeah, I think
Yeah.
you're right. And I like the way you said this here. This is smaller than 1/2. This one here is also smaller than 1/2. If you add 2 fractions that are both smaller than 1/2,
They
when
might.
when you add them together, they're going to be pretty close to 1/2. So that was a good way to estimate. And maybe later on we can actually find out what the real answer is. But that's a good way to start. So if you finally do this problem and find the real answer, we can compare the real answer to what your estimate is and see if your answer makes sense.
Yep.
Okay, good way to start.
There
huh?
you go. Nicely done. So I
like
know
it.
he's still looking at that like, all right, I think that's what we did there. that looks pretty good, but let's go ahead and take a look at that. But anyway, we'll do some more estimating in a little bit. But now, time for today's Math in the News. All right, today's Math in the News has to do with Roman numerals, and one of the places that a lot of kids see Roman numerals for the first time, and sometimes the only time, is on Super Bowl Sunday.
That's right.
So Ray, does that look familiar at all?
Yes, it does.
Okay, so did you happen to see the Super Bowl?
Yes, we did. I did. I watched it with my family.
All right, good. And Scott, did you have a stake in the Super Bowl, a favorite team, or one you wanted to win?
Didn't have
or
much of
anything?
a steak. No, I had a pizza instead. So, but it was
Enjoy
all.
the
Oh
day.
yeah, there you go.
There you go.
But no, I didn't really mind too much about who won. It's always about getting together with the family. Good job.
All
Ray,
right.
I like
So
that.
there is the logo for this year's Super Bowl, which was 55. And if you know Roman numerals, you know that L stands for 50.
Yeah.
And the V is for 5, so it's 55. So we can take a look at some of the other Super Bowls that have gone on in the past. And you see Super Bowl 5 is where they finally started using Roman numerals. Otherwise, it was the championship game. Lamar Hunt, who I believe was associated with the Kansas City Chiefs,
Right.
introduced Roman numerals to keep track of Super Bowls. All right. And we can see there's a lot of ones here. And the one I remember, there was a cartoon. And where is it? Let me see if we can find it here for you. Right here. This one right here, XL. All right. Now, do you remember what XL is offhand?
XL, it should be 40. Is
Right.
that right?
Now, the reason why some people can remember that, it was a cartoon, I forget where I saw this, but they said once you hit 40, you go to an XL, right, as far as your size and stuff like that.
Yeah,
So it kind of, it's like, oh, there we go, right?
Yeah.
But anyway, these are the different logos and what they look like. Here are the Roman numerals. So we've got 1, 2, 3, and then 4 is 1 away from 5. You're taking 1. So if you put it before the V, you're taking 1 away from it. All right? Just like when we get down to 10, which is an X, 1 before it is 9. Because you can see we don't have 4 ones like that for the number 4. And then you can see that once you get going on, you've got L for 50, C for 100, D for 500, and M for 1,000. So those are the common Roman numerals, and you've got some numbers that go along there with it. So, Ray,
Yes.
pick a number between 1 and 100.
50.
50. All right, easy enough. Do you remember what that Roman numeral is?
That Roman numeral, I don't remember.
Look
but
on
Well,
the
take a
chart,
look at the chart right now.
There it is.
it's an L.
So it's an L. If I said I want you to represent 53, what would you write to make 53?
L, and then 3 lines.
Right. So L-I-I-I.
Yeah.
I-I-I.
Aye.
Ay. All right, there you go. So you got 53, right? There you go. Somebody got the little ay there, all right. So anyway, let's, so there is some math to it.
Hey,
and
all right.
Roman numerals, you can see, we can add 1,223 plus 1114. So here, we can see we have our 1,200, and there's 23. Okay? Plus 1,100, there's our 10, and this 4 makes 14. All right? So when you add them, what they did is they just took the Roman numerals and added them up separately. So they took the M's, which were 1,000, right, and added those up separately. So you've got 2 of them. All right? Take all of the C's, which are 100, add those up. You've got the 3 10s, which is 30. But now, Ray, what happened here? They had 3 and 4 makes 7, but you can't put 7 I's, can you?
No.
So what did they do at the end? Can you tell what they did with 7 instead of putting 7 I's? Do you remember what 5 is?
They added a 5.
Yeah, right?
And
Because there is
2
no,
I's.
you can't just put 7 I's, right? Because then you're going to go, I. Right? That's not going to work. So anyway, that's a little math using Roman numerals. And Ray, I've got a challenge for you right now. All right? Now we know that X, well, what do you mean? This is a great
I've done
big
this
problem.
before. I've done this before.
All right.
All right, good. So what one would you move? Because right now it says 11 plus 1 equals 10. So now you're not actually going to be able to physically move them, but just tell us what you would do. And you can only move one. And there's 3 different ways to do this, so you only have to come up with one. Now, if you need help, you've got a helper over there in Scott. I don't know how much help he'll be, but you can ask him.
Tell me what you're thinking there, Ray. Just talk out loud a little bit. Sometimes it helps to kind of voice what your thoughts are. Right now, you understand it says 11 plus 1. It should be 12, right?
Yeah.
So there's no other matchsticks that we can put over here to make a 12. That's not going to work.
I'm thinking we should move one of like
Good
one of
idea.
this
Yeah.
one, this one, or this one.
Okay, which one? Let's just pick one of them and see if we can move it around and make it work.
I'm gonna pick this one since.
So the one that goes straight up and down here?
Yeah.
Okay, so that would be 11 minus 1 equals what? 10. That's
10.
great, but we'd still be waving that matchstick, huh?
Where to go?
It's a good start. Yeah,
So
we had to
that, you know
put it
what, I'll
somewhere.
give you that. That's one.
Okay.
That's cool.
Yeah.
But now instead of taking one and taking it away, take one and move it so it's still
Yeah.
part of the problem.
So that was a good start. I like that a lot. So we got rid of that one. So which one of those do you want to move? How about the first one? What if you move the first one?
This one.
Yeah. So let's say I'm going to take that matchstick. I'm going to have it in my hand here. And it's going to say 10 plus 1 equals what? What's 10 plus 1?
11.
11. But what does that say?
10.
So where should I put this one? You just got to say 11, right? How do I make 11? I have this matchstick in my hand. We took it out of here. 10 plus 1 equals 11. How do I make that say 11?
You add 1 right there.
That's it. So the one that we took away from here, we can put at the very end and make it be
and
true,
then
right?
yeah.
Yeah, then it works. Hey, all right. So we did one where we took one away, and we did one where we actually moved it over, and it worked both ways.
Very
Yeah.
nice. And kids at home and adults also, if you can think it the other way, there's another way to do that where you're moving just one matchstick to still make that a true mathematical sentence. You can call in and tell Mick, hey, I got that other way to do it. Anyway, that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. Ray is a 5th grade student from Stockdale Elementary, loves the challenge of school, loves to do more work, challenging work, and as part of the GATE program, so you get a little bit more with that in that as well. You estimated one problem. We're going to estimate another one now. All right? Here we go. So you guys can put this up on the board.
Okay.
You added one last time, so let's subtract one. 4/5, 4 over 5, minus 1/2. So estimate that if you would please.
Okay, Ray, what do you want to do here?
We can do the same as the last problem, just subtracting this time.
There you go.
'Cause
So how do you want to estimate 4/5? What is it close to?
it's closer to 1.
Oh, I like that. So the two numbers, the numerator and the denominator, are very similar, right? So
Yeah.
you're saying this one is right about 1, right? And then what about the 1/2? Do you want to estimate that? Is that closer to 0 or 1, or what do you want to do with that one?
Just keep it as 1/2.
Kind of keep it, yeah. I think
Yeah.
that's a good idea. So that one's like right in the middle anyway. It's not closer to 0 or 1. So if you had to estimate this, right? Basically, this problem says 1 minus 1/2. What do you think the answer is going to be about? Not quite, right? But it should be close to what?
1/2.
1/2, that's it. And those little wavy lines mean not exactly equal,
Yeah.
but pretty close,
Yeah.
right? So when we do 4/5 minus 1/2, it should be somewhere around 1/2. And if you had to do the problem, we need to do it, but tell me what you would do in the very first step. What would you do to start this problem out if you're actually subtracting to do it?
Like how?
Yeah, you said you knew how to do addition, subtraction, right? And you can't do it like it says it because something's wrong. What would you change to get this problem ready to go?
I would change. I don't get the question.
What would you do to start the problem? 4/5 minus 1/2. How would you start that problem?
I just estimate the numbers.
We did that part, right? But
Yeah.
if you actually had to do the real problem, what has to be the same for you to subtract fractions?
You have to get.
Well, you're thinking about it, I can tell. You have to get what the same?
You have to get the.
If you
Bottom
can't,
You have
number
to
or
get
top
the
number? Which one?
denominator.
That's it.
I was going to say, he's probably trying to think of the vocabulary
there you
word
go.
instead of just going top bottom right now. But
That's right. So you got to get the bottom number the same, right? That's called the denominator. That's it. So if you had to start this problem, we would start by making the bottom numbers the same.
Yeah.
And real quick, here's your quiz. What is that bottom number in this problem? What would it be?
The denominator.
Yeah. And what would the number actually be in this problem? What would the denominator be for those two fractions?
It would be a. It has to be the biggest number, right?
Well, 2 won't go into 5, so that won't quite
No.
work. It's going to be bigger than both of them, actually.
5 won't go into 2 though.
That's right.
So
So what's 5 times 2?
5 times 2 is 10.
That's it. So if we can make both these fractions into a fraction with the denominator of 10, that would be a good way to start this one, right? So that would be our first step. And we know that the answer is somewhere around 1/2. So
Yeah.
we're prepared to do this thing forward and backward now. We will await further instructions.
okay. Don't wait too long because here it comes right now.
Okay.
All right. So, all right. Based on how you guys just did that problem, we're through estimating.
Okay.
All right. Do you have a basic idea of what you're doing with the estimating?
Yeah.
You're not going to do estimating too many times in this right now. You need to make sure that you can add and subtract fractions first.
Right.
All right.
Okay.
So clear the board. Let's go ahead with your next part in your book, and let's get you solid on this.
Okay.
7/10 minus 1/2. So there's no estimating. You can estimate in your head if you want to get an idea, but I actually need you to solve the problem.
Good idea. Okay, Ray, this is all you, buddy. Pick up that black pen and go to town. What are you going to do? And talk me through it. You said you had a neat way to do this?
I did,
Okay.
but you know what? 2 goes in. So this is the way I do it. It's a little bit of a long process,
It's all right.
but
Show me what you got. Long isn't bad.
yeah, I just write the lowest denominator.
Mm-hmm.
So I write 1/2,
Mm-hmm.
and then I need a times 5. I do this,
Okay.
and then 1 times 5 equals 5. Then 2 times 5 equals 10.
Gotcha.
So I
great
do
start.
7/10.
Okay.
I do 7/10 minus 5/10
And now you
equals
can do the problem, right?
2/10.
Good for you. And you got those denominators the same before you started. So you knew exactly what to do. Now, would you submit 2/10 as the final answer in this problem?
Yes, you would, right?
The question
you
is,
would.
would you? I would.
I would.
Would you?
Yeah.
Take a look at that
you
fraction
could
real
do.
quick and see if
I
you
just
can-
want to bring this. This is a good point you guys are on right now, and I know where you're going with this.
Sure.
If he submitted 2/10, he would get that correct.
Yep.
However, Ray, always make sure you look at the
Simplify.
directions. Okay. Whoa. What did you say?
Simplify.
Oh, well, if you want to simplify, let's see what you do there.
Let's do it.
That's equivalent to 1/5
How'd you know that?
because
Show me a little bit of math right after 2/10. How would you make it into 1/5? I like that idea.
well,
but
I
how would
just
you do
know
it?
because 1/5 times 2 equals 5 times 2 is 10, and then 1 times 2 is 2.
Good. So if you had to go backwards, I love the math you did here, right? But we're trying to go backwards from 2/10 to 1/5, and that's all we have right here, right? We have 2/10, this answer right here, and we want to make it into a new one. So instead of multiplying, what would you do instead? What's the opposite of multiply?
The opposite of multiply is divide.
That's it. So if you had to simplify this one, you could do the same thing, 2 over 2, right? And let's see what your final answer would be. What is 2 divided by 2?
1,
And what is 10 divided by 2?
5.
5. So there's your answer, and that's what we're shooting for, right? This is simplified form. I like the way that you're using that vocabulary there.
Yeah.
1/5. I like also that you have this idea in your mind, but if you had a fraction and you didn't know what the actual answer was in your mind, this is a wonderful way to do it by dividing by the same number top and bottom.
All
Good
right.
job.
Nicely done, boys. Erase the board. I've got another one for you.
Oh, man. I think you think Ray thought he was off the hook. Nope.
He's
Next
off
one.
the hook with that problem. Now we're going to add. So we
Okay.
have 7/8, 7 over 8, plus 1/3.
Okay.
Okay. Tell me what to do. Actually, don't even tell me what to do. Tell me what you're going to do, and you can do it with that pen.
Well, 3 can't go into 8 completely, so
That's true.
this is the type of math that I've never actually
Okay. Well, we did it.
I haven't practiced.
That's all right. We did it before when we estimated. Okay. So would you say that we still have to get to a point where both of the denominators are the same? Is that necessary for this problem?
No.
We're adding, right?
Yeah, we're
Yeah,
adding.
we still have to do that. So we're not going to get away with that. So we're going to rewrite this problem here in a minute, but we have to figure out what that denominator is going to be that's the same. So you just said 3 doesn't go into 8, and I think you're right.
Yes.
What is the lowest number you can think of that 3 goes into
2.
and 8 goes into? Has to be 8 or higher, right?
Yeah.
So we can do multiples. 8 times 1 is 8. That doesn't work. What's 8 times 2?
8 times 2 is 16.
16. Does 3 go into 16?
Not completely.
No. I mean, it does with the remainder. What's the next one? What's the next multiple of 8?
We already did 3, right?
What's 8 times 3?
8 times 3 is 24. Yeah, it does.
That's it. And one of the ways you can do this is you can always multiply the bottom together. No matter what problem you have, addition or subtraction with fractions, you can always multiply the bottom two denominators together to get your new denominator. Okay? So what I'm going to do is I'm going to write down what you just said here. I'm going to write down 24, and then your job is to make 7/8 into 24ths and 1/3 into 24ths. Can you do that at the bottom, please, below the original problem? The answer is yes, Ray. The answer is yes, buddy. Here you go. Ready? 7/8, and you want to make this into a new fraction with 24 at the bottom. You can do it. How does 8 become 24?
8 becomes 24 by multiplying it by 3.
Show us. Go ahead and write times 3, right below that equal sign.
Okay. Times 3.
Put a 3 there. Times 3.
Times 3.
Now do that at the top.
Okay, 7 times 3
And what do you get?
equals 7 times 3 is 14, 15, 21.
That's it. So the first fraction now is 21 over 24. Can you do the same thing for 1/3, please? We have to change 1/3 into a fraction
1/3.
with 24 on the bottom, right?
So do the exact same thing, right? Yeah.
But you're not going to multiply times 3, are you? What are you going to multiply by instead?
You're going to multiply it times
3 times what is 24?
3 times 3 times.
Well, how did we get there in the first place? Look at the problem. What are the two numbers we have? 8 and 3, right?
Mm-hmm.
So 3 times what is 24?
3 times 8
That's it. So write down times 8 on the bottom.
times 8,
And times 8 on the top.
and then times 8.
And what do you get? Oh, this problem looks a lot more fun now, right?
Yeah.
Because that denominator is going to stay the same. Can you add the top, please?
Okay. 8 times. Okay, so I'm gonna do times.
No times.
Oh, no.
Look at the problem that I've written. 21 over 24 plus 8 over 24. Just add the top two numbers.
Oh yeah, that's easy.
Because it's all ready to go for us now, right? We did the hard
Yeah.
work.
Yeah, so that's pretty easy. That's
Yeah. So what do you get?
9 24s.
That's it.
But we have to simplify.
Ah, here we go. There you go. You beat me to the
So-
question. So how are we going to simplify this one?
1 and 24. 29 minus 24 is 5. So 1 and 5. 24th.
That's it. So you changed from an improper fraction to a mixed number, and you definitely simplified that. Last question for you. Can you reduce 5 over 24? Can you simplify it any further?
No.
I think you're right. Good job.
Nicely done, guys. Great work right there. And for your efforts, you've got yourself a meal courtesy of our friends at Chick-fil-A. So congratulations on that. I'm sure you'll have a great meal. I always do when I'm there. Phone tutors are available until 5:30. We'll be back with more right after this. Well, the sixth grade students here at KCSOS have been working on circles and looking first of all at the stats in order to make the circle graph. So we've been using a baseball card, looking at one of the famous baseball players during the 1990s, Ken Griffey Jr., and we've been looking specifically at the year 1994. We first of all figured out the plate appearances. Who remembers how to do that? What did we have to do to find plate appearances?
We had to add the AB plus home runs.
The BB, right? The base on ball, right? Correct. So we got 489 plate appearances. Then we were looking at home runs. And how many home runs did he hit during 1994?
40.
40 home runs? Okay. So then with that information, we can make a fraction, a decimal, and a percent. Then, in order to make a circle graph, we need to figure out the number of degrees in that circle graph to satisfy the number of home runs. All right? So let's go ahead and start doing that. So we've got 40 over 489. That came out to a percentage, right, of 8%, because we first of all had to do the decimal. So now, with your calculators, take the decimal 0.0818. And once again, how many degrees are in a circle?
360.
So times that by 360. And when we do that, what is the whole number that it will round to?
29.
29. So we need 29 degrees. All right? So with your circle graph and your protractor, so we're going to put 29 degrees down here, and we're going to set it up, and we can see that 29 is going to be a little less than 30. So where the 30 mark is, we're going to go 1 degree less, and you're going to have to mark it on the outside of the circle probably. All right? Then move your protractor and connect the points. Now you don't have to extend outside the circle. Just go to where it would be. And there we can see we have a 29 degree part of the circle graph. All right? And what does that 29 degrees represent? What kinds of hits were those? Were those home runs, right? So inside that little piece, we're going to put the abbreviation for home run. Right? There we go. So what I would like you guys to do is now, instead of getting a home run, which is the best thing you could do, right? What's one of the worst things that could happen when you're at bat? Strike out. All right? So what I want you to do is still look at 1994. All right? And look for SO, which is strikeout. And how many strikeouts were there in 1994?
73.
73. So go ahead and put 73 on your paper under SO for strikeout. And it's 73 out of how many at-bats? Plate appearances.
489.
So you're going to put 73 over 489. Now what do you think you need to do once you have that ratio? Divide it, right? So use your calculators, divide it. Then what the students will do is once they have the decimal equivalent, figure out the percent, take that number, turn it into a number of degrees for the 360. They can add the next part to the circle graph, putting baseball and mathematics, a lot of it, all together with the 6th grade students here at KCSOS. Man, I am on it right now. That was a close call. Oh, right on the table. Oh, I got 2 big ones coming up now. Oh, Kendall. Ooh. Irene, you ready? I'm gonna try. Oh, so close. But I made it all the way across the room. Check that out. And once again, a big thanks to all of those students that came down and helped us out. We had some great math activities and they were all great to work with. So once again, thanks to all of those 6th grade students. We do have phone tutors available until 5:30 this afternoon, but time now for today's Museum Moment. And visiting with us today, we have somebody from the Bakersfield Museum of Art, Alli. How are you today?
Hi, Mike. I'm doing well. Thank you.
So what is your role with the Museum of Art?
So my position at the museum is as development coordinator. Because the museum is a nonprofit, development basically means fundraising. So we do fundraising all year long with special events when it's not COVID times, and membership, sponsorships, exhibits, education programs. So I help assist all of that at the museum with my wonderful coworkers.
Well, we certainly do appreciate everything that the Bakersfield Museum of Art has been doing with us so far this year. And we especially thank you because without you, there is no Bakersfield Museum of Art kind of going on. Thank you once again. With you right now, you have Ray, a 5th grade student from Stockdale. So what are you guys going to be doing?
So today we are going to celebrate music. The museum, we are currently closed, but we are opening a new exhibit that we're sharing online that's celebrating Bakersfield's rich music history of the Bakersfield sound. So my background is in music. I grew up taking piano lessons, so I wanted to share a little bit of that with Ray and everybody watching today. So Ray, have you ever taken a music class at school or?
I did learn how to play the recorder a little bit, but nothing else because of the pandemic, so.
Yeah. Okay, so we're going to do a little bit of music theory today. So I've already started by just writing out the basic notes. So music and math are directly related. And studies have shown too that kids who study music do better in math at school. So there's definitely a part of the brain that connects those areas. So we are starting with the basics. So the first thing to know is the quarter note. The quarter note gets 1 beat. Okay, so that would just be like a simple 1.
Yes.
And then we have a half note which doubles, so that gets 2 beats. So 1, 2. Or if you were playing on a piano, you would hold the key for 2 counts.
Yes.
And then we have what's called a dotted half note. That gets 3 beats. So basically it's like a half note. If you covered up that dot, the dot adds 1 count to it.
Okay.
So 3 beats there. And then we have a whole note.
Which is 4.
Good. Excellent. Which gets 4 beats. Okay. Now on this side, smaller than a quarter note is what's called an eighth note. An eighth note gets half of a beat.
Ooh, how do you do that?
So that would just be a quicker one. And then even smaller than that, if you're playing a song that's really fast, we have what's called a 16th note. So it's kind of like fractions here. This would be like 1/8, and this would be 1/16. And that gets a quarter of a beat, okay? So we need 2 16th notes to make a half note, or an eighth note.
And you need
We
2
need
half
2
notes.
eighth notes
Or
to
eight
make a
notes.
quarter note. We need 2 quarter notes to make a half note. We would need, what would we need to make a dotted half note?
1. We'd need 1.
We would need 1 beat from the quarter and 2 beats from the half note to make a dotted half note for 3.
And we'd need 1 from the quarter and then 1 to the dotted half note to make a whole.
Yes. What's another way you could make a whole note using
2 using 2 halves.
2 half notes? Yeah, exactly. So I like to kind of think of it, a quarter note kind of like a quarter, like a coin. So you need 4 quarters to make $1. So you would need 4 quarter notes to make a whole note, right? Awesome. Okay, so because I grew up playing piano, we use what's called a staff. These are just the lines and spaces.
Yes.
Have you seen this before?
Yes, I have. Yes, I have.
Good. So every line and every space correlates to a key on the piano.
Yes.
And that's a bigger lesson that we'd have to do a different day, but for today we're just talking about timing. So let's start off by, I'm going to draw a half note, and I want you to grab this pen,
Okay, thank
and
you.
you're going to practice drawing. So what note would we need here to make 4 beats in this measure? So the measure is just this group right here, okay? That's a measure. We already have 2 counts,
We want to make 4.
and we want to make 4. What note could we use?
We could use another half.
Yeah, do you want to write a half note right there?
Sure. We would use
Exactly. Perfect. So this is going to be beats 1 and 2, and this is going to be beats 3
3 and 4.
and 4. So we're using what's called common time or standard time 4/4. That means that there's 4 beats in every measure, and every one of these groups has to equal 4. Okay, so I'm going to do another one here. I'm going to do a quarter note for beat 1. Now, could you find one note that will complete that measure?
It would be the dotted.
Yes. Got to get that dot in there, huh? And that's for beats 2, 3,
And 4.
and 4. Awesome. Okay, we are doing great. So now I'm going to do, how about, I'm going to do a dotted half note for beats 1, 2, and 3. What note would you add?
I would add a quarter note.
A quarter note.
Yep.
Yep. And that completes that measure. Okay, now for the last one, I want you to draw one note that would make 4 beats for that whole measure.
That would be a whole note.
A whole note, exactly. And that's beats 1, 2, 3,
and 4.
and 4. Good, so let's go through. We just wrote a song together. So we wrote 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Awesome. Okay, let's keep going. So this time I want to use 1/8 notes and 16th notes. So this is kind of where we get into the fractions a little bit, but it's going to be great. You're going to love it. So I'm going to start with a dotted, oops, wasn't supposed to color that in. So I'm going to start with a dotted half note, which how many beats does that get?
3.
Good, and we're in 4 times. So we're looking for 4 beats for every measure. So if we wanted to do 1/8 notes, how many 1/8 notes would we need to complete this measure?
2 8 notes.
Yes, wonderful. So you're going to draw the head of the note there, then it goes up and over and down. So they connect, and then they fill in. So when you have 2
would you do 2 lines on the 16th?
Yeah, you would. Let's try that. So, say again, I did a dotted half note for beats 1, 2, and 3. Okay, this is beat 4. And we do an and sign for the half beat. So if we need one more count here, but I want to use 16th notes, how many 16th notes would we need to create one beat?
4.
Yes. Okay, so I want you to go ahead and write those in.
Okay.
4 little notes on the line. You can draw the head of the note first, so the circle.
Okay.
And color it in. 1.
And then I go boop.
Good.
and
Let's
boop.
draw the heads. So draw 4 heads. 2, 3, and 4. Then we're going to draw the stem of the note, which goes up like this. And this one. Good. And then you're going to draw the 2 lines all the way across. Yeah, good. Awesome. Okay. So this is beats 1, 2, and 3. Now we have to kind of break it down, so we go 4, E, and da. So we can break down that one count into 4 parts, right? But we're still getting 4 beats in every measure. So let's count these. We have 1, 2, 3, 4, and. See how that's faster?
Yeah.
1, 2, 3, 4, E, and da.
4 E and
It's a quick beat because it's only getting a quarter of a beat. So those move really fast, okay?
Okay.
Let's do one more. I want you to draw, using only 1/8 notes, I want you to come up with 4 beats. Here, I'll erase this.
Using only 8 notes?
Mm-hmm.
Okay.
So I'll give you a hint. They each get a half.
That'd be 8.
There
There'd
you
be
go.
8 of them.
So you're going to do 4 pairs.
So,
Yeah. So you'll do like, that's 1 pair. And then your connect. So do 3 more pairs for me.
okay. Then they connect.
Good.
Oh.
Yep. And then,
Another one.
And then the stem goes up and over and down. And 1 more. Up and over and down. You got
They're
it.
kind of sloppy.
So we're going to go 1 and 2 and 3 and 4 and. And that completes our measure for 4 counts.
There you go. Nicely done, Alli. That was a great lesson right there. And thank you once again. If somebody needed to get a hold of you guys at the Bakersfield Museum of Art to learn more about what you do, where could they go?
Yeah, so don't come to the museum, unfortunately, because we are closed. We're hoping to open soon, but meanwhile, you can go to our website. It's bmoa.org, and we have tons of things online. Thursday night at 7, you can log on and check out our new exhibitions, including the one about the Bakersfield Sound.
All right. Thank you very much for that. Thank you, Alli, for coming in today. We do have phone tutors available until 5:30. We'll be back with more right after this.
So, you say you want to travel through time, skip ahead to the future. Oh, wander back through the past to fix some terrible mistake you made long ago. Well, you can't, at least with our current known technologies. Humans have been able to slow down time by experimenting with speed and gravity, For instance, the clocks in our GPS satellites that orbit our planet are faster than the ones here on Earth because they are further away and not affected by the Earth's gravity as much. Every second, we are traveling through time. We are traveling 1 second per second through time. We are time travelers! I feel like we need official jackets or patches. No, now that I think about it, patches? We don't need any patches. So we are already traveling forward through time, but skipping through time is the stuff of science fiction. Now. Traveling backwards in time will probably end in paradox, and yeah, there's the technology issue. We can, however, see into the past by looking up into space. Since light travels at 186,000 miles per second, it will travel 6 trillion miles in 1 year. In the northern hemisphere, the brightest star that we can see other than our sun is Sirius. Why so serious? In the constellation Canis Major, Sirius isn't a solo star. It's part of a 2-star solar system that is 8.6 light years away from us. And the photons of energy are finally released from the star. They have lost so much energy that we can see them. Well, if we wait long enough. Remember light speed. When the light leaves Sirius, it takes 8.6 years to get here. So if you look up tonight and glimpse Sirius, the dog star, you will be seeing it as it was almost 9 years ago. One of the few galaxies we can see without technology from Earth is Andromeda. Look towards the constellation of Andromeda in the fall months, and if you are lucky enough to spot it, you are looking back in time 2.5 million years. So, fellow time travelers, be careful out there, and remember, no paradoxes.
Never can tell what you're going to learn from Camp Keep. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. We are going straight through until we hit April, so if you do need some math help, that's exactly what we're here for. We have Ray, a 5th grade student from Stockdale Elementary. And Ray, how long have you been at Stockdale?
For 6 years.
So since kindergarten?
Since kindergarten.
All right, good. Well, you know what? Next year in 6th grade, hopefully you have an opportunity to go to Camp Keep and can experience that next year.
Yeah.
All right? So you have estimated fractions, you have subtracted fractions, you
Yes.
have added fractions, and now we come to the next step, multiply fractions. So along with Scott, kind of explain to him anything that you think you might be able to do now, and if you're stuck, he's there to help you out.
Okay, so right away I see that 5 does not go into, 5 goes into 6 only one time.
And you're looking at the denominators, right?
Yeah.
Ray, are you ready? I'm going to blow your mind. The wonderful thing about multiplying fractions, the bottom numbers, the denominators,
Get
do
multiplied.
not need to be the same.
No way.
Isn't that cool?
Yeah.
So multiplying fractions is kind of a neat deal because you don't have to do a bunch of setup like we did for addition and subtraction. You've done the hard part. Those ones take a lot more time. Literally, multiplication, all you need to do a multiplication problem with fractions is multiply straight across the top and straight across the bottom. Can you pick up that black pen and do that, please?
Yes, I can.
Yes, I can. All right.
I was about to take the cap off. So, right, 5 times 6 equals 30.
Yep.
And then 2 times 5 equals 10, which simplifies to 1/3.
You did simplify that really well. And tell me what you divided by to simplify it. How did you go from 10 over 30 to 1 over 3? What did you divide by?
I didn't. Did I divide?
Well, you had to divide the same top and the bottom like we did the simplifying last time. I know you can do it in your head, but we wanted to see if we could identify the math that's going on in your head. So when you see some really big numbers that you don't know in your head, you can actually find a math way to do it. So what number goes into 10 and 30? In other words, what did you divide by here? How about this question? 10 divided by what equals 1?
10.
Yeah. And see how you divided by 10 here as well? 30 divided by 10 is 30. So you divided by 10 over 10. So when you're reducing or when you're simplifying like you want to do, make sure you're dividing by the same number top and bottom. So when you get a fraction you can't do in your head, that's the mathematical way to do it, okay?
Okay.
Great job. I'm glad you simplified there. I bet you we have another one coming.
That's soon.
Okay.
We're going to leave that one on the board because
All
there's
right.
something else I want you to do with that problem in a little bit.
Sure.
But Ray, come on over here real quick. And since we were using matchsticks with those Roman numerals before, I figured we'd do a little something with toothpicks right now, and kind of like that, all right? But this is going to be a little more spatial reasoning, all right?
Okay.
How many squares do you see there?
1, 2, 3, 4. 1, 2, 3, 4, 5, and then this giant square, so 6.
Good. So I'm glad that you were able to see that big one also makes a square, okay? Now, here's what I want you to do. I want you to remove 3 toothpicks, okay? You're not going to put them anywhere in there. You're going to remove 3 of them to leave only 3 squares, okay? So you have to remove 3 toothpicks to leave 3 squares of the same size.
So there can't be any. So what happens if I did this? Could that like?
Okay, now you've only removed 2. You have to remove 3.
I know.
So
but
let's say you remove that. So what do you want to find out?
if
That
there
would-
was still 3 sides of a square, but not the 4th side, would that
That
still
wouldn't make a
count?
square, would it? Because you need 4 sides.
Okay.
So right now you have 4 by removing 2, but I want you to put those 2 back. Unless you want to leave those 2 out. You have to remove 3 and have 3 squares. And all you will see are 3 squares.
Okay. So can I put those?
Yeah, you
back?
put those back. You can move whatever ones you want. Try it again.
Okay. Well. Well, that would be hard.
Do you think it's impossible?
I don't think it's impossible.
Correct you are, young man. Nothing is impossible when we come on to do the math.
Well, I would know if I removed these 3. That would make 1, 2, 3, but then that would
Yeah, you've got extra stuff there, and we don't want that. We just want to see 3 squares.
Okay. So I'll put these back, and then 1, 2, 3. If I remove these 3, that would make 1, 2, 3, 4 squares, so I can't do that.
Is there a way that you could remove 2 toothpicks and completely eliminate a square right now?
Yes, there is. I could do that.
There you go. All right, so that's an idea, right? Now, I'm not saying those are the 2, but you can see how you can remove 2 and you can get rid of a whole square, right? But put those. I'm going to just tell you that those aren't 2 of them. Okay.
Okay. I could do this, and then have 4.
But we only want 3, so you can only remove 1 more.
Well. I don't think I can do that.
You want a hint?
Yeah, sure.
All right, put those other ones back.
Okay.
I'm going to remove 2 of them, and you remove the 3rd one. Okay, if I take these 2 out, you only can remove 1 toothpick to leave 3 squares. And I'll give you about 20 seconds.
20. Okay.
I mean, we don't go all night here, brother.
Okay.
So think about 1, where if you took, check you out, dude. What made you go to that one real quick?
Well, I noticed that these 2 surrounding,
Good.
I can't take this away because that wouldn't be a square. I couldn't take this away.
Good, so you did take that one away, and that does leave 3 squares. Nicely done. You know what, we'll check out some more with you in a little bit. But the Mars rover Perseverance will touch down on the surface of the red planet Thursday, February 18th, around noon Pacific time. Its mission, in part, is to gather soil for testing as scientists search for an answer to the big question: has there ever been life on Mars? Well, Do the Math is counting down the days to this big STEAM event with special coverage. We go behind the scenes to see how this mission came together and what we can expect from Perseverance once it lands on Mars.
We are in Death Valley testing terrain relative navigation, the new technology for Mars 2020. The terrain in Death Valley is very much like Mars. It has a lot of sand dunes and steep slopes. It's quite similar to the landing site that Mars 2020 will be going to. We're taking a copy of the system that will be on the spacecraft, and we're testing it in the way that it would be used during the flight mission.
Terrain relative navigation gives the vehicle the ability to figure out where it is. This is kind of along the same lines of what the Apollo astronauts did with people in the loop back in the day. Those guys were looking out the window and looking for different craters and other features on the moon that they knew of from the maps we had of the moon. So that way they could figure out where they are and figure out where they needed to land to be safe. So for the first time here on Mars, we're automating that.
What terrain relative navigation gives you is the ability to avoid hazards that you already know about. So large hazards, hills, craters, things that you've seen before. With the camera, we take images as we're descending, and we match pieces of the image to orbital imagery that we have stored on board. And if we make many of these matches, we're able to figure out where we are relative to the map.
If we didn't have terrain relative navigation, the probability of landing safely at Jezero Crater is about 80 to 85%. But with Mars 2020, we can actually bring that probability of success of landing safely at Jezero Crater all the way up to 99% safe every single time.
We don't have an astronaut that we can put on board Mars 2020, but we can put this system, this terrain relative navigation system, so that the spacecraft could figure it out on its own.
I could see it being used on lunar missions, science missions, as well as human missions. Future Mars missions, of course, Mars sample return, Europa lander, landing on a comet, pretty much everywhere you want to land, you're going to want to have terrain relative navigation.
Well, Perseverance touches down on the Martian surface Thursday, February 18th around noon. Live coverage of this special STEAM event begins at 11:15 a.m. right here on KETN, a service of your Kern County Superintendent of Schools office. And this is some big doing. You even know this is coming on, right?
Yes.
So be looking for it next week. All right, you guys, I'm going to give you a couple of seconds. Scott, go along with Ray and show how we can simplify before we actually multiply.
Sure. Now remember, Ray, we want to get to 1/3, right?
Yes.
We want to see if we can skip this 10 over 30 part, right?
Yes.
So here's the deal. I'm going to draw a big line in the middle of this problem. Do you see any numbers that are the same on the top and the bottom?
This one's the same as that.
Yep. So what if we just cross those both out? That's kind of nice, right? Kind of a good deal. 5 divided by 5. It's just 1. It goes away. What about 2 and 6? What can you divide 2 and 6 by?
12.
You can divide them both by. They go into 12. That's right. But what
They
can
go
you divide?
into 12.
What can you divide them by?
3. No.
Almost. They're both even, right?
Yes.
You can divide them by?
You can
2.
divide them by
Yeah, by 2.
2.
So what's 2 divided by 2?
2 divided by 2 is 1.
What's 6 divided by 2?
3.
There you go. Wrap
So we
it
ended
up.
up
We
with
got
1/3.
1/3.
And we skipped
Nicely
the other
done. Hey, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.